AB Tutoring. I'm Dominic. Let's learn about Newton's laws. Sir Isaac Newton developed 3 laws of motion. The first of these laws, which is also known as the law of inertia, states that a body at rest stays at rest and a body in uniform motion stays in motion unless it is acted upon by another resultant force. Newton's second law states that the rate of change in an object's momentum is a product of its mass and its acceleration. The rate of change of a momentum of a body is proportional to the applied force and the direction of this force. From this law, we can derive the equation force is equal to the mass, represented by m, times the final velocity, v, minus the mass times the initial velocity, u, all over time in seconds. Another way to write this formula will also be force is equal to mass times acceleration. Newton's third law states that if body A exerts a force on body B exerts an equal but oppositely directed force on body A. Some of you may know it as every action has an equal but oppositely directed reaction. Momentum. The linear momentum of a body is a product of its mass and its velocity. Therefore, the formula for momentum is mass times velocity. The unit of momentum is kilogram meters per second or Newton seconds. Using Newton's second law, we can use this to find the change in momentum. So, force, as you know, is newtons times seconds. The unit of momentum is Newton seconds. So to find the change in momentum in an object, you multiply both sides by time, and this will be an equation for change in momentum. The law of conservation of momentum states that in the absence of external forces, the total momentum of a system of bodies is constant. This means that the momentum before and after an object has come in contact with another object, the total momentum remains the same. When a bullet is fired, the momentum of the bullet leaving the gun is equally but oppositely directed backwards, and this is known as recoil. Therefore, the total momentum of the bullet being fired is 0. For example, a car traveling north that weighs 1,000 kilograms, traveling at a speed of 20 meters per second, comes in contact with a car traveling south, weighing 1,500 kilograms at a speed of 18 meters per second. So to determine the common velocity of the vehicles after collision, assuming they stick together, we'll use the law of conservation of momentum. So the total momentum before collision will be equal to the total momentum after collision. And as you can recall, momentum will be the mass times acceleration. So the total momentum. And because the car traveling south is going the opposite direction to the car traveling north, we will denote 18 meters per second as minus 18. That will leave us with 20,000 minus 27. So that will be minus 7,000. So the total momentum before the collision will be minus 7,000. Now for the second part of the question, which says assuming they stick together, so that would be the total momentum after will be equal to the sum of their mass times their common velocity. So now we have our equation. Minus 7,000 Newton seconds is equal to 2,500 of the velocity. transpose for V, and you will get minus 7,000 over 2,500. Therefore, V is equal to negative 2.8 meters per second. The negative sign indicates that the vehicles are now traveling south because we use north as a positive value at the start of the equation. And that's it for Newton's laws, which include momentum. Thank you for watching AB Tutoring, and see you next time.